Your warm greetings to one and all. In this session, let's learn about encapsulation. Encapsulation is nothing but wrapping up of data and information in a single unit. Encapsulation is defined as binding together the data and the functions that manipulate them. So the picture depicts the class where class consists of data members and methods. So wrapping up of variables and methods into a single unit, which is called as class, is called as encapsulation. So the picture depicts the encapsulation. Encapsulation mainly improves readability, maintainability, and security by grouping data and methods together. Properties of encapsulation. We have two important properties. The first one is data protection. Encapsulation protects the internal state of an object by keeping its data members private. Access to and modifying of these private variables is restricted only to the class public methods and ensuring the controlled and secure data manipulation. The next one is information hiding. Encapsulation hides the internal implementation details of a class from external code. Only the public interface of the class is accessible, providing the abstraction and simplifying the usage of the class while allowing the internal implementation to be modified without impacting the external code. Let's have an example program for encapsulation. We have defined the class definition for class sample. Private access specifier is given for the variables which are declared inside the class. We have the variable A of integer data type and assigned with value 5. We have the variable B of integer data type and assigned with value 4. Next, we have public access specifier for the functions which is declared inside the class. We have the function add, which has void return type and it has no arguments inside it. So here we have the variable C of integer data type and assigned with an expression A plus B. Using cout statement, we have displayed the value of the variable C to the user. Now let's see how the program gets executed. So we all know that the execution starts from main function. So here in the main function, we have declared the object yes for the class sample. Using the object yes, we have accessed the function add, which is available in the class sample. So now control moves to the class sample and executes the add function. Here, the value of the variable a and b, that is 5 plus 4, is added and stored in the variable c. So the c has the value 9. Using cout statement, the value of the variable c, that is 9, is displayed to the user as shown in the output. Let's explore this example program. Here, the variables are declared using private access specifier, which cannot be accessed outside the class. Member functions are declared using public access specifier, which can be accessed outside the class. In main function, the object yes of class sample access the add member function since it is declared as public. The next statement, s.a, tries to access the private variable a, which is declared in class sample. If we execute this statement, we will get error. Since the statement is trying to access the private variable, which is declared in class sample. Encapsulation is achieved through access specifiers that controls the visibility of class members, allowing the hiding and implementation details, and it also provides a well-defined interface for interaction with the objects. Features of encapsulation. We cannot access any function from the class directly. We need an object to access that function that is using the member variables of that class. The function which we are making inside the class must use only the member variables which are declared inside the class. Then only it is called as encapsulation. Encapsulation improves readability, maintainability, and security by grouping the data and methods together. It helps to control the modification of our data members. Thank you all.